We are talking about power and potential energy. Power is the rate of work, or in other words, work over time. From the equation, we can determine some of the relationships. For example, if we increase work, we will also increase power if given the same amount of time. On the other hand, if we increase the amount of time something is done, which means it's slower, then we decrease the amount of power that is accomplished. If we can do some work faster, meaning in a smaller amount of time, we can increase the power output. When working power problems, you have to remember that work is force times displacement, a subject that we've already covered. And that to find the force, you take the mass given times gravity, or times 10, to get the normal force. This is something you can usually accomplish in your head. You have to keep in mind your units as you do this, since force is given in newtons and distance is given in meters. When we go to do power, power is a newton meter, or a joule, per second. When we change talking about the mass of something to talking about the normal force of something, that is given in newtons. A joule per second is given the name of a watt, which is abbreviated capital letter W. So a joule per second is the same thing as a watt. Power can also be given in horsepower, HP, but that's a different conversion. Now to talk about potential energy. Potential energy is the energy associated with an object's position. It is also referred to as gravitational potential energy. We calculate this by taking the mass times gravity times height. The units for this are a kilogram meter per second, which is together a newton, times meters. A newton meter, remember, is a joule. So potential energy, kinetic energy, and work all share the same unit of joule, or newton meter. Relationships can also be determined from the equation. If we were to increase the height of an object, we would increase its potential energy. Likewise, if we increase its mass, we could also increase its potential energy. However, if we were comparing two objects, for example, one with a greater mass but a lower height, it's possible that proportionally they would contain the same potential energy. The law of conservation of energy says, energy can neither be created nor destroyed, but can change from form to form, meaning potential energy and kinetic energy can convert back and forth in a system. Because the change in kinetic energy is equal to the change in potential energy, the graph of total energy over time would look like this, because as you can see, there is no overall change. They just convert back and forth so that the total amount stays equal. In our example of a roller coaster, we notice that at the top of the ride, we have maximum potential energy and minimum kinetic energy. As the car goes downhill, that changes. Potential drops as kinetic increases until the bottom of the ride, where we're at maximum kinetic energy and minimum potential energy. As the car climbs the hill, it gains its potential energy due to its position in relation to gravity, so that at the top of the hill, we're at maximum potential energy. In the example of the pendulum swinging back and forth, at point B, we would have maximum potential energy because that's where it stops and changes direction. The height from the top of the swing there to the bottom of the swing would determine how much potential energy it has, plus the mass of the ball. At point A here, the bottom of the swing, we would be at maximum kinetic energy, the energy having converted from potential to kinetic. We can see in this diagram that at the top of the diving board, little dude has its maximum potential energy of 10 joules. If he were to dive off at the bottom right before he hits the water, he'll have a maximum kinetic of 10 joules also. The quantity is the same. But notice on the trip down that the potential proportionally decreases to 0 as the kinetic proportionally increases from 0 to 10. This is demonstrating the law of conservation of energy. We can work these problems if we're given the mass and the height by calculating potential energy at the top and then assuming the law of conservation of energy that at the bottom the answer will be the same for the maximum kinetic energy without having to calculate kinetic using 1/2 mv squared. Because of the equation for kinetic energy, 1/2 mv squared, the relationship of velocity to kinetic energy looks like this because velocity is squared. This is an exponential curve. However, for potential energy, this relationship is a direct relationship, not exponential, so that as height increases, potential energy would increase proportionally, and it would graph looking like this. This is just a quick overview of power and potential energy for your quiz. Please review the worksheets that you've already completed on power and potential energy. There are some additional notes in your Edmodo folder for work, power, and energy. And you can always review this video again. So good luck.